Welcome back. Now let us learn one of the little bit advanced topic, GLMNet. GLMNet is very famous. It was famous when it was invented, and it is little bit better than the linear regression because it is more flexible. And in my experience, still works very good when you have the sparse data. But for learning purpose, let us go ahead and learn it. And 170 is that we are loading the data again, and 173 to 177 we are dividing the data in 85% to and 15%. GLMNet has been defined in the library called GLMNet. So line 180 we are loading it, and 182 we are making a list of all the predictive variables. And GLM need the matrix data, not the data table. So in 185 we are simply converting our data table to matrix. And this is the way the command over here. This is the object name. This is the data with all the independent variable, and this is the dependent variable over here. And alpha is I hope you recollect we had learned the regularization. So regularization we had learned over here. I'm just trying to bring it here. So this is the things, lasso versus ridge. So what it says that it says alpha equal to 1, it means the lasso, and alpha equal to 0 ridge penalty. And so if you take the 0.5, it means in between something. And family Gaussian, that dependent variable, if you recollect, ours was near to the Gaussian, that is a normal. Okay, and standardized equal to false, it means do not scale the data. Our data is already in the standard format. This is what it means. So 188 we are building the model, and 189 we are seeing the summary. So summary, it is trying to show the sum of these things. Few of you may not understand, so nothing to worry about. Okay, now we are predicting it. So but before prediction, on 192 we are converting to matrix because it needs the matrix, and 193 we are converting it, and it takes something called lambda, and which lambda is already there in the model which we have already calculated. So there are a few more things we can do with the lambda. This one I'll request you to read the documentation of the GLMNet. And 193 we are predicting it. 194 we are just making it in a vector form, because if you see, this will not within a vector form, so it is there in this data form. So 194 we are making it as vector, and 197 onwards, here we are calculating these two different kinds of error. And now error has come 2.45 and 3.09. I hope you recollect what was the error for the linear one. Linear one, the regression was 2.5. So if you see that the error has improved a little bit, and we'll see that how to make it a bit more. And this is for viewing the graph for both actual and predicted one. And this one I have already explained. There's one classwork I want you to do. So if you see that this is the line wise, do it on the point wise, not the line wise. That is what this will be your classwork. Please go and do it. And the residual plot will do it in line 211. So before, let us clean up the image folder. And 211 we are doing the residual image. Yes, it has done it, all these things. And I have already explained this one in the past, that previous one. So I'll request you that you please look it and see that if you don't understand, I'll explain you again. But always you should start with this one. QQ plot looks good. Only the few things, 1 or 2 points are going away. This residual normal, but not really good normal. not good normal, and not outlier on the residual as well, so looking good. And that's all for GLMnet, and we are detaching into 1.3. So that's all for the GLMnet, and till now we have learned the basic way to do the regression, and I hope you have understood. And it again, I'm just emphasizing that not necessarily you will be doing the regression in this way, but from the concept point of view, you should be aware of it. Okay, so that's all. And, that's all for basically regression. Now we'll move to advanced one. Thanks for watching it. See you in the next one.